Hey everybody, welcome to our next webinar on rendering automotive assets. This presentation builds on top of the previous webinar, so hopefully you guys will find something useful in it regardless of your skill level or time that you've had in Unreal Engine. We're going to be moving pretty quickly and we're going to be covering off a variety of tips and tricks as well as best practices and workflows. So thanks again for taking the time to check this out, and let's hop to it. Cheers everybody. All right, so the first thing that I want to talk to you guys about is something that's pretty important if you're working with Unreal 4.25 with older projects. So if you open an old project that originally started in Unreal 4.24 using the Automotive Material Pack and you look at it in Unreal 4.25, there's a pretty good chance that it's not going to be rendering correctly because we changed the way clear coat works at the shader level pretty substantially in Unreal 4.25. So to illustrate that and what's wrong, I've got two car paints here. One of them uses the master material from the Automotive Material Pack that was Unreal 4.24, and one of them uses the updated version of that master material that's compatible with Unreal 4.25. So you can see the 4.24 version has the wrong effect happening on the Fresnel effect here. So this facing ratio, the glancing angles, are kind of glowing and they're really, really bright. And that's because this 4.24 master material of the car paint doesn't take into account the changes that were made for the updated clear coat model. So how do you know if you've got the old master material? It's actually pretty easy if you just navigate to that master material and bring it up in the material editor. And if you follow off of metallic here, you're basically going to follow that line back and you're going to find binder opacity. So if binder opacity is passing through a Fresnel node, you know that's the old 4.24 version of the master material, which is totally cool if you're working in Unreal 4.24. But if you've brought this project into 4.25, you're going to get these weird glowing highlights on your kind of glancing angles, which is going to be wrong. So what you want to do is you want to update the master materials to 4.25. So how do you do that? Well, step one is making sure that you get your, you re-download the Automotive Material Pack. So how do you do that? You go to go to your library in the Epic Games Launcher, scroll down to the bottom where you get to the vault. The vault's all the stuff you've downloaded from the marketplace. If you search for auto, it's going to show you that in my vault, basically meaning on my computer, I've got the Automotive Material Pack and it's taking up 3 gigabytes. Now, often you're gonna see an update button. Sometimes that update button's not there, but you know there's a new version of that content on the marketplace. So to force a refresh, all you have to do is remove your local content, delete the files basically, and then re-add them to a project. Now make sure when you add it to a project, you add it to a 4.25 project because it will then download the correct files from the marketplace. The marketplace has 4.24 versions and 4.25 versions. So make sure you add it into a 4.25 project. So once you've done that, you're going to have a new project then that basically has the updated Automotive Material Masters in it, which is exactly what you want. So how do you move that information from one project to another project? Well, there's a couple ways of doing that. An easy way of doing it is open that new project you just made that has the updated 4.25 masters in it and navigate to that master material in the content browser by double-clicking down into the Automotive Materials, going into the masters, going to that car paint master, right-clicking on top of that and saying Asset Actions Migrate. You bring that up, it's going to say, this is the material and this is all the stuff associated with it that we're going to move to or copy over or migrate over to another project. So you say, okay, it's going to ask you to then basically select a content folder and whatever project you want to add this to, go to your project that, you want to overwrite, the new version of that master material in and select the content folder and just say, go. As soon as you say select, it'll basically go through and right over those old master materials. Now, another way of doing it is to actually do it in Windows. So you can go to the file browser for that project that you just made that has the updated 4.25 version, and it's basically the same thing. So go into the content folder, go into the materials, go into the masters, grab that car paint master, copy that guy, and then navigate in Windows to, the other project and just overwrite it or paste it over. So same basic idea. One of them's done through Windows and then one of them's done through Unreal, but it's essentially doing the same thing. So once you've done that, you're going to get your updated master, which then obviously renders correctly with the 425 clear coat, which is pretty cool. And there's a few other changes that were made to the materials in 425, the 425 version of the Automotive material pack. I think wood is one of the big ones. It has the ability to change the direction of the grain with a UV rotate and things like that. So the next thing that I want to talk to you guys about is a question that actually came up in the last webinar, and it came up in YouTube a couple of times too. And that is, a bunch of people saw the color calibrator that I had in my project and they were like, oh, that's really cool. Where'd you get that? Can I have that? And you know what? That actually comes with Unreal. So how do you find it? Well, if you go to your content browser, go to the view options in the lower right-hand corner and click on show plugin content. And I always turn on show engine content. So by turning on those two options, if you go down to your show hide source panel and you search for color, you can see that we now have in the engine content, this color calibrator, and this static mesh color calibrator is that guy. So you just kind of drag that guy out and you get this little dude that lets you obviously dial in your lighting really nicely. It's got 50% gray, a Macbeth chart, all the stuff that you saw in that first webinar. So that's pretty straightforward. So when you're done with that, always make sure that you clear this filter out, because if you don't clear that filter out, when you go back and start looking, in your base, content folder, it's going to be using this filter, which is wrong. So just always make sure you clear that guy out, and then you can obviously get back to your main content folder really easily. So with that done, the next thing I want to talk to you guys about is console variables. So we talked a bit about this in the first webinar, and I'm going to go into it a little bit more in depth. So the first thing that I want to do is I'm going to bring up my output log. So if you go to Developer Tools and bring output log up, I've just got it docked down here. The output log is really nice. It basically is just running back a series of information as you work inside of Unreal. But you can also use it to query console variables to see what the values are set at. So if we go to our content browser, and I hover over top of something, you can see I get these tooltips popping up really, really quickly. So I want to slow that down. I find it a little distracting. It's a little aggressive. So what I'm going to do is I'm going to go to my command, and I'm going to click inside of it and then use my up-down arrow key to roll through a list of the last few commands I've used in this project. And you can see that I have something called summons tooltips. So what I'm going to do is I'm just going to say summons tooltip delay, but I'm not going to put a value there. And the reason I'm not going to put a value there is if you just type a console variable with the output log up, it's going to go through, it's going to tell you what the value is currently at, and it's also going to tell you how it has been set. So if it says set by constructor, that means it's using the default, like however Unreal Engine defaultly sets that value. So that's pretty straightforward. So if I want to write a different value into that instead of 0.15 seconds, I'm just going to set this to be a summons delay of 4 seconds. So by doing that, now if I hover over top of something, it's going to take 4 seconds until that tooltip pops up. So you can see that it took 4 seconds to do it. Now, if I go back and I run this command without a value again and hit return, you can see that this time it's been set by console. So it lets you query values and also see what's actually being used to set that attribute for that console variable. So the output log gives you, really valuable information. I guess that's what I'm trying to show you guys. So the next thing that you can do with this that's pretty interesting is with ray tracing, it can get a little confusing, right? Because you can set, if you start typing ray tracing, there's a ton of console variables for ray tracing. Now, if you remember from the first webinar, a lot of those ray tracing attributes can also be set with a post-process volume, right? So let's go ahead and just hit return on that guy so it's not all sparkly. So what happens here? Well, this is where it can get kind of confusing because you can set a console variable down here, or you could use the attribute inside of the post-process volume to set that. So if we come down here, currently by default, the post-process volume when you first open a project is what's going to be driving all of these attributes. So any attribute that's inside of here. So if we go into ray trace reflections and I start to play with that, you can see as I drop that down, I'm changing what's using reflection probes versus ray tracing. Now, at any given time, I could override this with a console variable. So if we look at our reflections right now, and we don't put a number there. So we just basically say max reflections roughness, hit return on that. You can see it's set to a value of -1 and it's set by constructor. So what -1 means, basically use what the constructor was, which in this example would be the post-process volume. So whenever you put a value of -1, it's going to kick back to the default. And the default for ray tracing is if there's a post-process volume in the scene, that's going to be what drives it when you put it to a value of -1. It basically puts it back to the default. And in this example, that's the post-process volume. So if I wanted to overdrive that and not have the post-process volume set it, of course I could do that. I could say max roughness set to 0.4. And as soon as I do that, you can see it's changed it. So now when I adjust this attribute, that slider isn't driving the max roughness value. It has no effect because I've manually set that with a console variable. So to get it back to get that back to using the post-process volume, all I have to do is hit my tilde key and set that guy to a value of -1. And as soon as I do that, it's now being driven by the post-process volume. So hopefully that makes sense to you guys. I know it's a little confusing that you can basically do it in two different ways, but the -1 turns it off and says, you know what, go back there and start looking at the post-process volume to get that value or get that attribute. So just keep that in mind. All right. So the next thing that I want to talk to you about with console variables is the fact that when we're playing with these console variables and I'm setting them, in the editor, they're not actually saved with the file. So if you want them to be saved with the project so that every time you open the project, those values are set, you need to do it in an INI file that lives inside of the project. So what does that mean? Well, let's go ahead and jump back into our project. So we'll go to the root of the project here. If we jump into the config folder, there's a default engine INI. So if we double click on this, a lot of the things that are set in this default engine INI are going to be like things that you set in the project settings, but there's a list of things in the default engine INI that I've manually entered into it. I've actually, in this text editor, added in all this stuff. So I've gone ahead and I've said, I want my denoiser to be set to 0. I want my height fog to be set to 0. My reflection captures has 1. So that means instead of falling to black, it's going to kick back to the reflection captures, all stuff that we looked at in the first webinar. And these, again, were all manually set by me in this INI file. Now, one thing to keep in mind is the syntax in the INI file is slightly different than the syntax that you set in the editor. Notice that it says r.reflections.denoiser equals 0. If we go to the Unreal Editor and I want to change that denoiser to equal 1, basically what you do is the console variable for that denoiser, instead of having the equal sign, it's just the name of the console variable, space, and then the attribute. So, you can see my reflections are now super, super soft. So if I want to set this back, all I have to do is go ahead and hit this to 0, and you can see that it's going to flip that guy back to, turning the denoiser off. So just keep in mind that the syntax is a little bit different between the INI file and Unreal in the console variable in the actual editor. So hopefully that makes sense to you guys, and I haven't completely confused you all. All right, so the next thing that we want to do is build a tool that works in the editor to manage our render settings. And this is really easy to do. If you go to the content browser and right click and say editor utilities and create a new editor utility widget, we'll give this guy a name. We'll call it Ren Editor Utility Widget because it's going to manage some render settings. And we just need to double click on that to bring up the editor. So this looks really similar to UMG. It's actually very similar, except instead of working in a runtime or a game version of the content, this is actually going to work in the editor. I'm going to build a tool that I can use in the editor. So what I want to do is I want to get rid of the canvas panel. That would be more for like a screen-based effect. I want to get a list of buttons. So we'll delete the canvas panel from the designer, and I'm going to go up to my palette and I'm going to search for box. I want to get a vertical list of buttons. So I'm just going to drag out a vertical box into the designer. So with that done, we'll clear our filter up here at the top of our palette, and we'll just start adding in a couple of buttons. So I'm going to drag out a button into the designer, and instead of being called button 168, we'll just give this a name that's a little bit more meaningful, like Enter Active. And I'm going to actually just highlight that and copy it because I want to add a text block on top of that guy And in my content for my text right here, I'm going to paste in the word interactive. So pretty straightforward. Go ahead and we'll click on that button one more time just to set its tint to something a little bit more appealing, like a blue-ish color. And we'll go ahead and we'll create another button by dragging it into the designer. We'll set its tint to be, I don't know, like a off red. And instead of being called button 267, we'll call this one high quality. And we'll just copy that guy. We'll add in a little bit of text on top of that button. And we'll go down here to our text content and paste in high quality. So with that done, we'll go ahead and we'll compile this. And we'll minimize it. And we're going to run it. So if you right click on top of that guy and you say run editor utility widget, it's going to go through. And there is my custom UI that I've made. Now, this can actually be docked anywhere in the user interface that I want. So I have an interactive button and a high quality button. Now, I click them, nothing happens. We haven't put any logic behind these buttons. So let's go ahead and do that now. And this is, again, pretty straightforward. Double click on it. And what we're going to do is instead of getting out of the layout area of this editor utility widget, we're going to jump into the graph. This is where we can start to build up blueprint code that is going to get executed by those buttons. So the first thing that we're going to do is we're going to go to the interactive button. We'll highlight that guy and we're going to say on click, give me an event. So when I click on the interactive button, I want it to execute a command. So I'm just going to literally drag out with my left mouse button and I'm going to search my executable actions for console. I want to execute a console command when that button is clicked. And the console commands, we've played around with a fair bit in this webinar and the last webinar. We want to set some of those ray trace attributes. So let's go ahead and minimize this guy down and hit the tilde key to bring up the console variables. We're going to set this max roughness. So I'm just going to highlight this guy. So r.raytracing reflections, max roughness. We're going to copy that guy with Control C, and we'll jump over into this editor utility widget, and we're going to paste that in there, and we're going to say that is equal to 0.4. Pretty straightforward. And hit return. So I want to create another on-clicked event for high quality. So we're going to highlight that guy. We're going to click the on-clicked event, and I'm going to basically take this and just duplicate it. So I also want this execution to be wired together. So I'll just drag those two guys together. And instead of the high quality setting a value of 0.4, what I'm going to do is every time I click that high quality button, I want it to fall back to whatever I set in the post-process volume. So this is pretty straightforward. We'll just say -1, which you saw us do earlier in the presentation. And now if we compile this and minimize this guy back down, and if we go back and hit interactive, you can see if I hit my tab key here, we are around 20 milliseconds, and you can see the change that happened. So when our reflection value is 0.4, you know, a lot of the pixels are kicking back and using a probe. If we hit high quality, it looks a little bit better, and we lost 5 milliseconds. Now, if we go back to our world outliner and we find that post-process volume, because we're in high quality mode right now, high quality mode had reflection set to -1, which basically means fall back to whatever that slider does in the post-process volume. So if we come down to ray trace reflections and we put this to something like 0.95, you can see, you know, we're up to 40 milliseconds. If we go back to our editor utility widget and we click the interactive button, we're down to 22 milliseconds, but we've lost some visual fidelity. So let's continue to build upon this. Let's go ahead and let's do another one. So instead of ray trace reflections, let's do ray tracing and let's do max bounce. That's another one that's pretty cool to play around with. So we're going to do max bounces. So let's go ahead and grab that guy. Let's jump back into this, and I'm going to execute out another console variable command. And we're going to basically paste this guy in here, and we're going to say our max bounces in interactive mode is set to 1. So it's going to do 1 bounce, and then we'll just Control W to duplicate that execute command. Again, wire these guys together and put this to a -1. So remember, when we go -1, what's going to happen is it's going to fall back to whatever the value is set in that post-process volume. So in our post-process volume, we have a max bounce of 3. So if we hit interactive, it's going to be really, really fast. Look at the reflections of the reflections. And then when we hit high quality, big changes in the look of this, as well as, pretty significant performance hit. But that's basically the idea. Now, the thing that's really cool about this is whatever I do with this editor utility widget, I can always push this into another project the same way that we pushed that material. You can go Asset, Actions, Migrate, and migrate this over to another project, or you could copy and paste it in Windows or in File Explorer to basically add it into another project. So you can start to build up a variety of tools. So I'm just going to go ahead and fast forward and add in a few more of these guys, and I'll show you the end results of that in just a second. All right, so here we are, and I've added in a couple more things. So if I click the interactive button, obviously, it gets really nice and fast, 60 frames a second, 16 milliseconds. And if I hit the high quality button, it slows down a little bit, but it looks substantially better. And then I've also got a lights on and a lights off. So if I turn the lights on, actually they were already on. If I hit the lights off, you can see that it changes in the headlights here a little bit. This is basically toggling on and off of a variety of point lights that are in the scene. So if we go back and look in the blueprint, you can see, I've added in a few more commands. So, we're changing this translucency samples, the skylight samples we're kind of playing around with, reflection samples, max bounce, and then max roughness. So a couple things. And then obviously for the high quality one, it's basically all -1. So it kicks back to that post-process volume. And then for the lights, I'm basically, again, executing on the click. I'm doing a get all actors of class. So that goes through and creates an array of all the point lights in the scene. And then it's basically going to run through each point light with a for each loop and basically either set them to visible or not visible. And essentially that's all I'm doing is turning the lights on and turning the lights off that are stored in that array. So very, very straightforward, very simple. And again, this is a tool that I could easily migrate or copy paste into any project that I want. So you can start to build up a variety of custom UI elements that allow you to give you a higher level of control inside of the actual editor, which is, I think, pretty cool. All right, so since we're talking about console variables and we're in high quality mode, I do want to show you guys a couple of other really useful console variables that you might want to turn on when you're in a higher quality setting. So one of them is if we just right click inside of here and just search out for ray tracing reflections. So if you kind of scroll down the list here, ray tracing reflections, max undercoat bounces. So if you take this guy, by default, what this is set to is 0. But if you put this to 1, you'll notice what's going to happen. It changes the look. So essentially what's happening now is the substrate is now actually getting a bounce of that ray. So it's technically more accurate. It costs a little bit of time, it costs some milliseconds there, but it actually is letting the ray bounce through the clear coat and then accurately calculating the roughness of the substrate underneath that clear coat. So that max roughness value or that max bounce value, if we put this back to 0, you can see the difference here. So, costs about 15 milliseconds, but it's technically not as accurate, right? So if you're doing an offline rendering process and you're trying to get the maximum quality, you're probably going to want to throw that max undercoat bounce to a value of 1. Okay, pretty straightforward. Now, the next one that I want to talk to you guys about really quickly is this one's actually really cool. So let's hit return on that and get rid of those little sparkles there. The next one that we're going to talk about is R sharpen, and I use this one a fair bit. So right now, this texture map on this tire and the metal flake that's happening across here, I want to sharpen the effect of my render a little bit. So if we hit our tilde key, you can see I've actually been playing around with this a little bit earlier. So our tone map sharpen. So if we put this to a value of 1, You can see as soon as I do that, and I hope this comes across in the stream. You know what? Let me overdrive that. It's a float, right? So if I put this to something like 5, it's going to get really, really sharp, really strong. That might be a little bit too much. I'm overdriving it, basically because I don't know what's going to happen with the stream. But this sharpen is just a beautiful, beautiful thing. I normally run that, 0.5, a value of 1, something like that. It looks great when you start to put depth of field on the camera too, but I really like with the metal flakes and, a lot of these kind of, these kind of texture maps on tires and things like that, just running that little R sharpen just gives it a little bit of sweetness, a little bit of polish. So hopefully you guys like that one. Let's go ahead and jump back to our bookmark here and just kind of move over. So the next thing I'm going to spend a few minutes talking about are LODs. That stands for level of detail. It allows you to have lower polygon geometry or lower polygon meshes based on how close they are to the camera or how much screen percentage they are taking up. So this increases performance as well as visual quality, and it reduces quad overdraw. There's lots of reasons why you want to set LODs up. So how do you do it? It's actually very straightforward inside of Unreal because it has an LOD tool that's built in that's actually pretty amazing. It's a really awesome polygon reduction tool. So here we are. I just double clicked on the static mesh to bring it up in the static mesh editor. And we're currently looking at LOD 0. This is the original mesh that was imported in from the CAD application, and it's comprised of 50,000 triangles. Now in the details panel, you can see there's an LOD section. So what I'm going to do is I'm going to increase the number of LODs from 1 up to 3. And as soon as I do that and I click the apply changes button, Unreal goes through and it basically creates 3 different versions of this geometry. So you have the original mesh, which is LOD 0. It's comprised of 50,000 triangles, and I'm just going to show this in wireframe so that you can kind of see me jumping through these guys. Then you have LOD 1, which has been reduced by 50%, so it's half the number of polys, 25,000. And then obviously we have LOD 2, which has been further reduced down to 25% of the original triangles, or 12,000 triangles. So if you put this to auto LOD, it's going to automatically switch between these based on this screen size value. So obviously LOD 0 is going to be a full value of 1. LOD 1 is going to be a screen size of 0.5. And this will be a screen size of 0.25. So if I go back to auto, as I zoom in and out, you can see the number changing as well as the poly count updating. You can see it pop right there. So it's basically reducing quad overdraw, and essentially you don't really see the change, right? When it's in a lit mode, these are such high polygon objects a lot of times with automotive data that you can really, you can reduce it down a fair bit and get a little bit of performance improvement out of there, which is pretty awesome. So let's go ahead and save that out, and let's jump back into the editor here, and I'm going to switch my mode to view my level of details in a color chart. So as I zoom in and out here, you can see basically it's cycling through colors as it moves through these LODs based on how close I am to those objects. So it gives you a nice visual representation of all those LODs that are actually included in this as it kind of pops through those, which is pretty awesome. So the next thing that we want to do is we want to actually go back into a lit mode here and talk about this headlight. So this data is the actual manufacturing data that we got from Audi. So there's certain areas like on these headlights where there's this kind of modeled in detail that's super, high polygon count. And that creates, this is a really hard thing for a ray tracer, for the interactive ray tracer to deal with, is this kind of grid pattern. So what I want to do is I actually want to create an LOD for that simplifies it. But instead of using a polygon reduction workflow, I want to replace that with a piece of geometry that I modeled in Maya, where I actually deleted this top piece of geometry that was that mesh, that kind of that grid pattern. So how do you do that? Well, it's basically very similar to what we just did for the wheel. If you bring up the static mesh editor for the headlight, so if we just go ahead and we grab this guy here and get this headlight 2, double click on it to bring up the static mesh editor. So in the static mesh editor, we've got these headlights, right? And it's 100,000 triangles, high polygon count object. And what I want to do is I want to replace this with a custom piece of geometry for LOD1. So how do you do it? Well, it's really straightforward. You just basically go in here and you say LOD import for level 1. So I'm going to import LOD level 1, and it essentially brings a file browser up. I'm going to load up this FBX file. We'll hit apply on that guy. It's going to go through, import in the data. And with that done, okay, that's cool. We now have LOD 0 and we have LOD 1. Now its screen size is set to 0. So what I want to do is I want to go to LOD 0, and you can actually overdrive this. Like you can see right now, my screen size percentage is 1.59. So what I want to do is I'm going to set LOD 0 up to a higher value, something like 2. Because I want to make LOD 1 turn on at a value over 1. So we'll say something like 1.5 is going to be where that guy is going to turn on. So if we put this back to auto, you can see as I get out a little bit further here, I'm at 1.3. We've now flicked off and we don't have that modeled in geometry. And then as I get closer to where that grid pattern becomes important to see, like when you're really close up there doing like a macro shot on that headlight, you might want to see that modeled in geometry. But when I'm further away, I want to just get rid of that so that it doesn't create that noise in the ray tracer. So that's just a couple of extra tips when working with LODs. You can obviously overdrive the screen size and load in custom geometry. So let's go ahead and jump out to the editor and see what that looks like in context. Let's just minimize this guy down, and you can see as I zoom out here, it's now switched. And you can see that we're not getting that buzzing that was happening nearly as bad in that. And as I start to get closer here, it does this nice little transition effect and turns on that mesh, that modeled in mesh. So really, really simple example of how you can use LODs to increase the visual quality and remove some of the noise that the ray tracer had. All right, let's move on to the next concept. All right, so to finish off, we're going to work with this G-coupe scene, and I'm going to show you how to get very high quality reflections without ray tracing. So this is a raster project. It's set up and ready to go into VR. You can see, it's 8 milliseconds to draw this scene right now. It's crazy, crazy fast. And even though it's a raster-based scene, so there's no RTX happening here, it's still got very, very high quality reflections happening. And this is being done with a combination of screen-based reflections. So those are going to be reflections that, the pixels have to be on screen to show up and reflect. It's a screen-based effect, combined with reflection captures that have been extremely strategically placed. And I'll go through my theory on how to place these so that you can match the results with your scenes. But the overall effect basically gives you smooth transitions between the screen-based reflections and the reflection captured reflection. So a perfect example is if you look at this dark spot here reflecting the door. So obviously that can be a screen-based reflection because it's that dark spot's on screen. But notice what happens as that transitions off of screen. There's really no change in that. So it's basically at this point now using the reflection capture. So the key here is to make sure that you position your reflection captures very, very precisely. So let me walk you through the ideology or the idea behind how I place these reflection captures. So if we go ahead and we look at this, I just turned on all the reflection captures. Essentially, I have very large cube-based reflection captures that are trying to grab the planes of the vehicle. So essentially, it sits out here in space and this back wall just touches the side of the car, and then the bottom of it is exactly aligned with the ground plane. So that's basically how I go through and I set up, reflections on, these big long swoops down the side of the car. Then I do the same thing on top of the hood here, where again, it's basically just barely touching into it and they transition into each other. Then the next thing that I do is around the wheels, I go ahead and I paste spherical reflection maps. Again, basically just covering the area where I want to add in detail on that wheel. Now, the next thing that I'm doing is I'm coming in here and I'm doing a combination of cube reflection maps to grab the big areas as well as some other ones in the corners here. So in the nooks and crannies, I'm going through and I'm actually setting up where these reflection captures would be. So it grabs the top surface and the bottom surface. And I basically have just introduced a few of these kind of in all the vertical areas and all the horizontal areas of the kind of intake on the car. Same thing on the back here. So again, I'm going to come in here and I'm going to be putting in a reflection captures sort of in the areas of these little nooks and crannies, sort of on the tail end of the car here to cover off this sort of rear. And then of course, this is going to be another cube reflection capture underneath. Again, just being very, very careful with how these guys interact with each other. It allows you to get these extremely smooth transitions between those reflection captures and the screen-based reflections. And without the screen-based reflections, like if we go in here and we grab the post-process volume and we turn off the screen-based reflections on this guy. So if we come down here to screen-based reflections and put this to 0, you can see that we're going to lose a lot of that sort of reflections of the hips of the car, the belt line, the shoulders, all that stuff. And I'm running the quality of this up at to 100% when I'm in desktop mode. Now I actually have another post-process volume that I can jump to when I go into VR mode that maybe I will, drop down the quality of those screen-based reflections just to give a little bit more performance. But in desktop mode, I'm still very, very fast at 125th a second, 8 milliseconds on the draw of this car. So that's basically the way I go through and set up the reflections. Now, another trick with reflections is I like to put them onto their own level. So to get your levels to show up, basically go in and say world, go in to Windows and say levels, and that essentially will load it. I have it docked over here. So what I like to do is I like to put the reflection captures on their own level. And the reason I do that is because if I'm working off of Perforce or I'm using some type of source control, those reflection captures can be, that map can be really big. So if I'm not recalculating that stuff over and over and sending it up and down to the people I'm collaborating with, it actually makes it a little bit faster. So you can see the effect when I turn off the contribution of the reflection captures. Like here you can see this is screen-based reflections, right? So you can see this is on screen, it's going to show up here, but as that transitions off, it just basically drops to dark because there's no reflection capture to kick that information back in. So if we turn the reflections back on, there they are with that smooth transition into the screen-based reflection. So, there's a couple of tips and tricks. Now, another thing that I always do when I'm using reflection captures, especially if I'm going to be building a car configurator that's got multiple colors, and I've actually got a couple of, I have a level variant set in here where I can switch to a blue or red, back to the silver. So what I do is when I calculate those reflections, I always calculate the reflections on a silver car. Now, yes, technically it would be more accurate to calculate blue reflections on a blue car and red reflections on a red car. But I find that if you do it on a silver car, when you switch between the colors in the configurator, it works out pretty good actually. So that's just another little tip to help you if you're trying to build a configurator that's going to work in runtime with reflection captures, contributing a lot to the overall look of the paint. My advice is to do it with a silver base and it just sort of blends in and looks pretty good. Now, the next thing that you can do is you can turn on SSGI, so screen-based global illumination. So if I hit my tilde key and hit my up arrow key, you can see that if I enable that SSGI, it dropped it down a little bit. I lost a few milliseconds there, but that overall look of that screen-based global illumination just further grounds the overall car and makes it look a little bit more photorealistic. So with these few things, basically really precise positioned reflection captures, and doing it with silver and some SSGI, you can get to a look that's actually quite similar to what ray tracing looks like. All right, so the final thing that we're going to talk about is cameras, and they're really, really awesome inside of Unreal. There's a couple of things you need to think about when you're working with Unreal and the executable version of your content. So I'm going to drop this camera down from a field of view to 90 to something like 50, just because I feel like that looks a little bit better. Now, here's the problem. When I go ahead and I hit play and jump into the runtime, what's going to happen is the default pawn is going to jump back and use that field of view of 90. So that's not really cool. That's not what we want to have happen. So we want to go ahead and get rid of that default pawn and build our own pawn that is going to be used during the runtime. Now, to do that, we're going to use a cinematic camera. And cinematic cameras they're great, right? They have this amazing depth of field. They're super high quality. So if we go ahead and show our placed actors and go to cinematic, you can drag and drop a cinematic camera into your scene. I've already got one inside of here. So if we go ahead and we look through that, you can see it's obviously got a field of view of something around 50. It's got this really nice depth of field happening. You can see that kind of, the focal point's kind of here, and then off the tire, it's a little bit blurred out. So what we want to do is we want to get a cinematic camera that's driving our runtime camera. So how do you do that? Well, it's really pretty straightforward. If you go into your world settings, in your world settings, you're going to have a game mode. Now, yours might be set to none by default. You can always create a new game mode. And once you create a new game mode by clicking the plus sign, you can start to add in custom pawns and things like that. So I've already got a game mode inside of here that I built up. It's called RTX game mode, even though this is not an RTX-based scene. This is 100% raster. And inside of there, it's using the default pawn. So what I'm going to do is I'm going to switch this from the default pawn over to this RTX pawn. And if we zoom in on this RTX pawn and double click on it, it was just a pawn that I made by clicking the plus sign. And I went and I said, add component. And then I added, like if you search for camera, you can see that you can add a Cine camera in there. So I added the Cine camera in. I turned on the use control pawn rotation. I turned off the aspect ratio, had the focal length set to 50, and then I'm tracking a focal point of that back tire. So that's basically what I've done. That's all you have to do. So now that I've got that set up, if we go ahead and we hit play, instead of using the default pawn, which would have jumped back to 90, what we're using now is a cinematic camera in runtime with a focal length of 50 and a depth of field focus settings tracking that back tire. So I get this really shallow depth of field shooting down the length of the car. We have these beautiful, reflections from the screen-based reflections blending into the reflection capture reflections. And obviously the screen-based SGI is in there, and it just looks really, really sweet. And again, this is 100% raster. This is ready to go into VR, super, super fast, can play back on a lightweight machine, and it looks pretty cool. So the final thing that I want to show you guys, and because we're running out of time so quickly, I'm just going to kind of talk you through it, but I will provide a link to the actual camera. I'm going to show you an autofocus camera system that I have set up. So let's go ahead and jump out of the runtime. We're going to switch our camera mode over to the autofocus pawn, and I'll zoom in on this guy and I'll double click on it just to show you what's going on. So same idea, we have a camera in the viewport, it's a Cine camera, and then in that graph, I've got some logic that I've built, and I'll just kind of give you it in a nutshell. So I'm creating this update depth of field. So I'm making a function, and I'm basically querying where the camera is. So from there, we're going to use a line trace. So it sends out a ray and it records the hit. So you can see that it's going to come out here. It's going to know where the camera is. It's going to send a ray out, record that hit, and then it's going to subtract those two from each other to get a length. And then that length is basically going to set the overall focal distance. So the manual focal distance is basically being generated by, tracing that ray from where the camera is, recording the hit, subtracting that from that, and that drives, it's basically measuring, what am I hitting? What's in the middle of my camera? And then that, essentially sets the camera up. And then the final thing is that we're setting the overall focal length with this variable here to 50. So it's really a simple little bit of logic, but it builds something that's really quite cool. So we've got that turned on. If we go ahead and hit play here, you can see it's going to start up, and just like that, as we kind of zoom around here, if I focus in on the tail of the car, it's in the center of the screen. It's going to be in focus, and then you can see it's going to pull focus to the background. So just by dropping down here, it's going to do a focus pull and focus on the car and blur the background out. And again, if I get the background in focus, the car comes out of focus. So it's literally just finding the middle of my screen, and that's what sets the focal point. So if I pull this nose off the car and shoot at that back concrete wall, that's obviously in focus. And then as I, rotate the camera and the nose of the car becomes the focal point, or the center of the screen, that becomes the focal distance. So it allows you to create this really, really nice little, adaptive like an autofocus system, exactly like you might want. So I'll include that in the description. Thank you so much for taking the time to watch the webinar. I truly appreciate your guys' time. These are, they're moving pretty quick, and, kind of the whole idea behind them is to show you guys stuff that hopefully inspires you. There's a bit of foundational stuff here, but hopefully no matter what your experience level with Unreal, you found something useful today. Thanks again for taking the time to check it out, and stay tuned for the next webinar soon. Cheers, everybody.